Students, good morning. Today I am going to solve a simple problem. This problem comes under the category of units and dimensions. Through this problem, we can learn more information on unit conversion, units and dimensions. Very simple problem. The problem is a gas is enclosed by a frictionless piston in a 0.3 meter 0.3 meter diameter cylinder. So a gas is confined in a piston cylinder arrangement. Frictionless piston cylinder arrangement. Frictionless. Frictionless piston cylinder arrangement. Gas. Good. What next? A metal block is placed on the piston. A metal block is placed on the piston. A metal block is placed on the piston. The weight of the piston and block rested on it together equal to 100 kg. This piston as well as weight together with 100 kg weight. So, weight of piston and weight is given. Piston and weight. The atmospheric pressure and acceleration due to gravity are 0.1.01325 bar and 9.792 meter per second square. So, one atmospheric pressure is 0.1.01325 bar, or one atmospheric pressure is equal to 1.01325 to 10 to the power of 5 Newton per meter square. So 1 bar is equal to 10 to the power of 5 Newton per meter square. First we should learn 1 bar is equal to 10 to the power of 5 Newton per meter square. Hence the atmospheric pressure is 1 atmosphere is equal to 1.01325 into 10 to the power of 5 Newton per meter square. So unit conversion from bar to Newton per meter square. Clear? Newton bar to Newton per meter square. 1 bar is equal to 10 to the power of 5 Newton per meter square. Hence 1 atmospheric pressure is equal to 0.1325 into 10 to the power of 5 Newton per meter square. Acceleration due to gravity G is equal to 9.792 meter per second square. The question is, calculate the force exerted by the atmosphere. Answer for section 1, force exerted by the atmosphere. So what is the definition for force? Force is nothing but, what is this? Force is nothing but, or pressure is equal to force per unit area. Pressure is equal to P is equal to force per unit area. Obviously, force F is equal to pressure into cross-sectional area. So, pressure P is given 1.01325 into 10 to the power of 5 cross-sectional area of a cylinder pi by 4 d square. Pi by 4 d square. Diameter is given 0.3 meter. So 0.3 whole square into meter square. This is Newton per meter square. This is Newton per meter square into area. Meter square gets cancelled. By default, the answer becomes in terms of Newton. What is the answer? 7160.47 Newton. Clear? A simple knowledge. Force is equal to pressure into cross-section area. This is obtained by pressure is equal to force per unit area. Clear? This is the answer for question A. Next B. What is the force exerted by the piston and weight on the gas? Force exerted by piston and weight. Again, Force is nothing but mass into acceleration. F is equal to mass into acceleration, ma. This is Newton's second law of motion. Mass is given 100 kg, piston as well as weight. Acceleration due to gravity is given 9.792. Hence force F is equal to 100 kg into 9.792 meter per second square. The answer is equal to 9.979.2 kg meter per second square. 1 kg meter per second square is equal to 1 Newton. Hence, this answer is equal to 979.2 Newton. This is force exerted by the atmosphere. This is force exerted by the piston and weight. Answer for third question. Total force exerted by the next one is total force. What about the total force? Total force is equal to 7160.47 979.20. Total becomes 8139.67 Newton total force. Question number 3. What is the pressure of the gas? What is the pressure of the gas? Question number C. Pressure of the gas. Again, pressure of the gas inside the cylinder. Pressure is nothing but force per unit area. The total force, pressure P is equal to force per unit area. The total force is equal to 8139.67 Newton divided by cross section area 5/4 d square. 5/4 0.3 square meter square, Newton per meter square. What is the answer? What is the answer? 1.152 into 10 to the power of 5 Newton per meter square. This is the answer. Already we are finding force from pressure. Now we are finding pressure from force. This is total force. Clear? This is the answer for section 3. Section 4, question 4b. If the gas expands on the application of heat, piston moves upward along with the weight by 0.5 meter from this level to this level. The initial height is unknown. Final height is unknown. The increase in height is given 0.5. Hence I am writing del Z or dz. Now the question is, what is the work done by the system? What is the work done by the system? Work done is equal to force into displacement dl or dz. dl or dz. What about the total force? 8139.67 Newton into displacement 0.5 meter. What is the answer? 4069.835 Newton meter. Newton meter means nothing but 1 joule is equal to 1 Newton meter. So the answer is equal to 4069.8 joules. This is the amount of work done. What is the next question? CDE. Right. What is the changes in potential energy of the piston and weight after gas expansion? Potential energy P is equal to mg del Z. So mass is equal to 100 kg. G is nothing but 9.792 meter per second square into dz is equal to 0.5 meter. The answer becomes kg meter per second square is nothing but Newton. Newton into meter is called joules. The answer is 489.6 6 Newton meter or 489.6 joules. This is the answer. Now my question is, what about the work done? How work done is performed? Thing is that an amount of heat is added to the system. My question is it possible to find the amount of heat added to the system? My next question is, you are predicted the potential energy. Potential energy increased or decreased? Increased means what is the source for increase in energy? The source for increase in energy is amount of heat added to the system. Is it possible to find out how much amount of heat added to the system? That means amount of work done is performed by certain amount of heat added to the system. Heat added to the system is exactly placed to perform the work. Hence, work done by the system, this much joules of energy or heat added to the system. The same amount of energy is placed to perform the work done. If work done is performed, is the energy was vanished? No, it is stored as potential energy in the system itself. The thing is, there is no chance to create or destroy energy. Energy can be converted into one form to another form. Heat energy is applied to perform work. The energy is completely utilized to perform the work. After work completion, what about the energy? Energy is stored as a potential energy. That's all. This is the information from this problem. Thank you.